This video we're going to do a significance test or hypothesis test using the binomial distribution. So it's a very simple one to do. So it says a die is thrown 20 times and it shows a 6 on 7 occasions. Zara believes that the die might be biased. Test this claim at the 5% level. If we got 7 out of 20 times, we get a 6, we might think that might be actually not okay. The dice might actually be biased, so we're going to test that using a significance test. Now the bits in blue here, you don't actually have to write down, they are the steps. So the first step is to state the null and the alternate hypothesis, and the probability of getting a 6 on a die is 1/6. So we're going to call P 1/6, the die is fair. And we believe the die is this is happening more times, so we're going to test that P is greater than 1/6. So the alternate hypothesis is P is greater than 1/6. The die is biased and is more likely to show a 6. State the type of test. Now, because we've got greater than, we've got a definite increase here. So as H1, so we look at H1 as greater than 1/6, then this is a definite increase, so we use a one-tailed test. Use a one-tailed test if you've got a definite increase or decrease, otherwise you use a two-tailed test. State the distribution. Okay, the die is thrown 20 times, so if we let x be the random variable, the number of 6s obtained in 20 throws of the die, so x will be binomially distributed with n20, and the probability of getting a 6 is 1/6. Right, now we calculate the test statistic. So we want to know the probability of x being bigger than or equal to 7 or more, and we do that by doing 1 minus the probability that x is less than or equal to 6. So that's going to be 1, and now we have to calculate this bit using the CDF function on your calculator. I have a TI in the SPY, but it can be done on the Casio Class Wiz and other types of calculator. So going to my my TI in the SPY. So when I turn it on, it looks like this. So I go to this one here, and I want to do menu. For this I want to do a statistical test, so I need to go to number 6, statistics, and go to what's known as stat test. No, sorry, I beg your pardon, we want to go to probability, and go to what is known as distributions, and go to binomial CDF. So it's probability, distributions, and binomial CDF. Click on this. So the number of trials was 20. The probability of success was 1 out of 6, which we can enter like that. Lower bound was 0. Now we want less than or equal to 6, so we want to put in here 6 and press OK. And then we need to do 1 minus our answer, control above the minus sign, and press equals, and that will give me my answer, which is 0.371. So putting in the numbers in, so 0.96286, and then doing 1 minus that, I get 0.03713. This is known as a p-value for this particular test. Now the rejection criteria. Now this represents 0.037 represents 3.71%. And therefore 0.0371 is less than 0.055%. Therefore we will reject H0 and claim there is significant evidence the die is biased. Okay. Now, don't have to do this, but it's quite good to look at this using a diagram. So if we just go back to my computer, and we'll go to this one here, which is GeoGebra. Now, this is the probability calculator in GeoGebra, which is this one here. Okay, so I have set n to be 20, the probability to be 1/6, that's a decimal equivalent, I want more than 7, x is more than or equal to 7, so I get that from here. Notice the probability is 0.0372, but if I move this slider here for 6, you'll see then I get 10%, 10.19%. So here this is 3.72%, which is less than 5%, but here this will be more than 5%. So if it was more than or equal to 6, we would not reject H0, but here we would reject H0. This is how it works. So there's a diagram of what we've just done. Okay, so this is the probability of x greater than or equal to 7 is 0.371. Don't worry about the discrepancy here. These are calculated from tables. This has been calculated using the calculator. Here, the rejection criteria will be here. There'll be a rejection line somewhere in the 6 where all of this would have to be 0.05, but this is less than 0.05, therefore we will reject H0. So, note, as 0.0371 is less than 0.055%, we would reject H0. This is how an hypothesis test works. We probably would not be expected to draw this in an exam. I hope you've understood, and I thank you very much for watching.